Hello and welcome to the very first Taqueria Office Hours. My name's Houston. I'm the product manager for Taqueria. This is Jeff, CEO at eCAD Labs, where we make all kinds of great tools for the Tezos ecosystem. These office hours are going to serve as a way for users and partners to get a feel for new features that are getting released and serve as a chance to ask questions and have an open discussion about the product. We'll be doing these every 2 weeks on a Wednesday at 11 o'clock Pacific time. And we hope you join us in the future. The recordings will also be posted on the eCAD Labs YouTube channel and will be available for future reference. The structure of these events is going to be doing some demos, so probably 2 to 3 demos each time, 5 to 10 minutes, showcasing some of the new features and different workflows that we're releasing. And then we'll have the rest of the session open for questions and comments. For those of you that are watching the stream on Twitter or YouTube, the YouTube chats will come into the restream chat here. But if you want to watch this on Twitter, please go to our Discord. We'll put a link up right now. And those will make it in here as well. So yeah, without further ado, I'm going to kick us off with a short little intro to Taqueria and show some of the basics. After that, we're going to have Jimmy walk through our Ligo developer workflow, some of our naming conventions and improvements we've made to make developers' lives easier. And then Ali is going to showcase the VS Code extension and some of the cool new features there. So let me get started. First off, I just want to show you the Taqueria website here. This is taqueria.io, and this is where you'll find the documentation and instructions to install. So if you come under Get Started here, you'll find instructions for various operating systems. Do note that Taqueria comes as a binary, which you have to download and install on your computer. It also has plugins, which are hosted on npm.js. And then there's a VS Code extension, which you can install directly through VS Code. Note that you do have to have the CLI, regardless of whether you're using the VS Code extension or not, because that's where the brains are. Just to show you a quick tour around our documentation here. You'll find under plugin references most of the tasks that Taqueria operates. Taqueria at the core is like a task runner, and these tasks are provided by various plugins, which allows you to kind of customize the stack that you use on a various project. As you can see, we've got plugins for compilers like Archetype, Ligo, SmartPy. We have a contract type type generation plugin, which essentially takes a Michelson contract and generates TypeScript types that you can use in your front end. We have an IPFS Panada plugin for publishing metadata, and a metadata plugin for actually creating that metadata. The testing is provided by a Jest plugin. We have Taqueria for doing deployments, and Tezos client for doing type checking and simulation. So these plugins kind of get extended over time. And if you want to reference what ones are available, you can come to the website right here. So now I'm going to share a VS Code window and show you some of the basics of Taqueria here. So this is a freshly initialized project. Running the command tacinit will put your project into this state. Essentially, the Taqueria project has two required folders and a hidden folder. The contracts folder is where your uncompiled contracts, Ligo, SmartPy, Archetype go. Artifacts is where your compiled Michelson that's generated during compilation will go. And this .tac directory is where Taqueria stores its configuration and state. In here, you'll find config.json, which is your configuration for networks and environments and various other bits. Accounts are also defined here. You can define these accounts and give them a starting balance in Mutez, and Taqueria can actually instantiate these accounts on a FlexTest sandbox or on a testnet and then fund them for you. So if you're starting from this route with a fresh project, you'll notice running tac doesn't do too much here, right? We've got init, opt-in, opt-out, install, uninstall, add contract, remove contract, list contracts, clean. So these are all core tasks to Taqueria. And in order to do a lot of the work that your developer is going to need to do, you're going to need to install plugins. Plugins are going to provide these tasks. So generally what you'll want to do is start installing the plugins that you'll need for a particular project. In this case, we're going to start by installing Ligo. So we'll run tac install Taqueria plugin Ligo. And what this is going to do is it's going to download the plugin from npm. You'll see that our config JSON has been updated where the plugin Ligo is now installed. And if we run tac again, you'll see now additional tasks have been added for tac compile and tac test for doing Ligo native testing. Also tac create, which allows you to instantiate a Ligo template. So you would repeat this process over and over for all the plugins that you want, and then you will have access to all the tasks that are required. We also have another path for creating a new project called scaffolding. What a scaffolding does is it pulls a pre-generated project that already has plugins installed and serves as a way to get up and running really quickly. So you scaffold a project and you can start it right up and start playing around and seeing how it works. Our default scaffold is called the Taco Shop. We also have an NFT scaffold and it's showcasing some of those features. So I'll just quickly show you what that looks like. What this is going to do is it's going to do all the setup required as well. So it's going to install all the plugins and do a cleanup of the Git folder, initialize the project. So it does take a couple minutes here. Also note that a lot of the plugins are based on Docker. So the first time you run certain commands, you may have to wait a little while, but after subsequent executions, it will be much, much quicker. If you want to find out more information on the scaffolds, you can visit the website. There's a scaffold pane, and it lists some details about the scaffolds, as well as has details on how to use them. So you can see your project was created successfully here, and if we So you'll see a Taco Shop demo here. You have a ready to go project, which has a bunch of contracts. It has an app, which is a front end React app, and that will present you a UI. So you can easily go and start this up and get up and running. Realize I am over time for the demo here, so I'll leave that here and we can pick that up another time. And we'll move on to our next demo.
Very nice, Houston. Thank you. So who's coming up in the next demo here?
Jimmy is going to do a demo of the Ligo workflow. Let's introduce Jimmy here.
Great.
Hi, Jimmy.
Stuff.
Oh, hey, we can hear you now. Hi, Jimmy. This is Jimmy. He's an engineer who's been working a lot with our compilers and overall developer workflows. He's implemented a lot of the features to make developing with Ligo a lot faster and easier. Next, we're doing a big focus on SmartPy. So if there's any SmartPy users out there, every 2 weeks we're pushing a release and new features are coming.
Right. Okay. So I guess I'll get started. So I was gonna bring some stuff. I'm gonna just delete, cancel that. Yeah. Thanks, Houston, for the introduction. Yeah. So for this session, I'm going to be demonstrating the Ligo workflow. So Taqueria provide a Ligo plugin, which uses the Ligo binary under the hood, but we provide multiple abstractions over it to make it easier to work with Ligo. And here I'm gonna do a demo from scratch. I'm gonna go from contract creation to compilation and deployment, and like interacting with the contract. Okay, so here we go. Let's see. So we could grab this entire thing. We don't need the test code. Oh, am I sharing? Can anyone see? Can everyone see?
No, you're not sharing at the moment, so I think that's probably the first thing you need to do here.
It says I'm sharing.
Oh, well, yeah. Well, let me see what I do here. There we go.
Oh, right. Okay. Cool. Right. Okay. So, right. Okay. Here, now we start the demo. I'm going to copy this thing from the Ligo website, and then I'm going to go here. This is my project. And then I will create a file. Let's call it counter. Okay, now we have the contract here. And then let's see how we could compile it. Okay, I'm going to compile this thing. Compilation counter Ligo. It's going to take the Ligo file, which is here, this one, and it's to compile it. So now you see that in artifacts, you see counter. But also, if you notice, there's so it succeeded, but it gave you some notes saying that, hey, if you wanna, there's we couldn't find storage file for you, and so we're gonna create it for you. And so this file is used for defining all the initial storage values for this contract in Ligo. So you could write your contract in Ligo. You can write your storage values in Ligo and parameter values in Ligo as well. Here's a parameter equivalent one. So right, let's see. So if you remember, I've only created the counter file, but these two were generated for you after the compile task. And yeah, and here under comments, predefined comments to instruct you, give you instructions on how to use this file. Basically, you define all your storage file values here according to this format. And it's based on the syntax flavor that you're using. So I'm using mligo. So it's going to give you the mligo syntax. And let's see. So the way you define the storage is in Ligo, you do storage. It's just an expression, a normal expression, Ligo expression. You could do 12, or yeah, 12. You could define more, storage 2, let's see. And yeah, you can even do like algebra as well. You can, so this gives you 17. Right? And for, let's see, for parameters, this is what you do. Define parameter values for when you want to interact with the contract. We're going to get to that later, but let's define it here. Param1 parameter. I'm following this syntax here. And it's going to be increment 1. The reason why it's increment 1 is because it's the increment constructor that's coming from here. It's based on the type of the parameter. So param1 is the value, the name of the variable, and parameter is the type. So yeah, this is syntax. And yeah, let's make another one. You can make as many as you want. Decrement now, decrement 15, let's see. Let's put 100 here. Right, okay. So let's go back and compile this contract again. And so like when you compile the Ligo contract, it tries to find the storage and parameter files associated with this contract. We use a naming convention as for this association. Basically the contract name, then the keyword storage list, and then Ligo. And it's gonna look for those. It's gonna compile those two files along with the contract. And so when you do this, let me pull out this thing. Here's artifacts here. See, it's generated for you. This is the counter contract. And these are the artifacts for the parameter, and it shows you in the table here. Shows you, hey, I've compiled this contract, and this is the artifact. And for this file, we've created these two artifacts for you because you define two storage values for it. For each storage value that you define in that file, it creates a Michelson code for the storage values. So let me go back to here. Right, contract, and let's look at this contract. It's the artifact, it's Michelson code, and you also have the another thing I forgot to mention is that the first of this is consider a default storage, and we'll get to that later. We'll get to why we decided to create this construct later. It comes in handy in deployment, right? But let's look at the artifacts. So this is the contract Michelson. This is the storage. It's just 12, pretty simple. Same with this, 17. But for parameters, it's left, right, and then left, left, blah, blah. So it's very useful when you when you have to define a very complex storage value for your contract. Like with this workflow, you don't have to do it in Michelson. You don't have to touch Michelson if you don't want to. You can just define everything in Ligo. And okay, now that we have this contract and the storage value, you could move on to deploying them. So let's see. Do the tac deploy counter, and that is going to deploy. Let's see. I'm going to deploy to a test net, actually, to GhostNet. So let's see what this thing do. So the tac deploy counter. Notice that I didn't specify any storage value here. This is going to, without specifying any storage value in the parameter, in the command, it's going to get the default storage. And another naming convention that we use is this thing, this naming convention. This file called counter.defaultstorage.tz or tz. So basically the name of the contract counter, and then dot the keyword default storage dot tz. But usually you don't have to worry about this naming convention because we generate it for you from the Ligo workflow. And later on, when I work on the SmartPy workflow, I'm gonna do the same. And user, if you're a user, you don't even have to know any naming. You don't actually have to know and be aware of any naming convention like parameter list, storage list, because first time you compile your contract, we're gonna give you a note. Hey, you can't find these things, so we're gonna create it for you, and we're gonna fill it with comments like so. So if you don't like reading documentations, that's okay, because everything is here. Okay, now it's deploy, and this is the address. You can actually go and look for it. And let's see. Okay. You see, this was created with 0 balance. And if you want to give it some balance, there's flags that you can specify. Okay, the last thing I'm going to do is to transfer or a call. Transfer, let's see, for the counter. Then I'm going to specify what parameter to use, because there are 3 entry points, right? There's the decrement, increment, and reset. Let's see, which one do I want to use? I want to use I want to increment by 100, so I'll use counter parameter param1. Counter dot parameter dot param1 dot tz. I'm gonna right in the ghost environment. So that is going to invoke the counter increment entry point. And then you'll see, so storage now is 12 because that's what I initialized the storage to. The default storage value is 12. That's why you see 12 here. But in the second, you can see 12 plus 100. If I refresh, see here. And that's the history. And I don't know if I'm out of time, but that's basically the demo for the legal workflow. This is the complete legal workflow. Yeah. Yeah.
That's great, Jimmy.
No problem.
Yeah, a couple things to add. So in Tezos, when you originate a smart contract, every smart contract typically has storage, and when the smart contract is called, the entry points are called on it. That typically changes the storage over time. But when you originate a contract, you need to tell the chain what to set the initial storage to, and that's often a kind of a finicky thing for developers to do. And so the features that Jimmy has implemented and demonstrated here today makes it easier for you to declare multiple different types of storage and multiple different types of parameters for entry points. And this makes the workflow for the developer easier and more repeatable. So that you don't have to be editing like a lot of different files, and you have this sort of declarative approach. So your development feedback loop gets quicker, and that's some of the value that's provided here as well. So thank you, Jimmy.
No problem, Jeff. Thanks, Houston and Jay.
Yeah,
Okay,
really,
yeah,
really excellent, Jimmy. And if any users have input or suggestions, bug reports, feel free to reach out on Discord, or you can find us on GitHub and open an issue there. We will welcome all feedback. So next up, we're going to have Ali, who's been working a lot on the VS Code extension. Give end-to-end experience through VS Code, including invoking entry points and using our new Michelin editor. So I'll let you take it away, Ali.
Hello, everyone. The VS Code extension is trying to make it easier for people who prefer GUIs over CLIs to be able to discover and use Taqueria's features. So we try to make it intuitive to find and use the features that you see Taqueria has, and you can already use them in the CLI, and make them available in the VS Code using the Taqueria's VS Code extension. So if you install the VS Code extension, you will see this icon in here. And the first thing that it does is that it does a system check to verify that Node.js and tag CLI are installed. And actually, if tag CLI is not installed, it can install it for you. I'm not going to try it here because it's already installed on my computer. But if the system check passes, then it gives you the ability to do a range of actions based on the current state of the project. So currently, I don't have any project open, and that's why it gives me two options. One is to initialize a new project, and the other is to scaffold the project based on one of the scaffolds that are available in the extension. It also gives us the ability to run commands from the command palette. So we can see that we have these commands available at the moment. These commands also change based on what is the current state of the project, as we will see later. So first, I'm going to initialize an empty project. And because I don't have any folder open, it's going to ask me to give it a folder. And I'm going to create a new folder for that and select that. So Taqueria will create an empty project in there, and then it will open it. So yes, this is the same project that you would see in project structure that you would see when you run tech init from the CLI. But here you see that the Taqueria extensions view is changed because we have a Taquified project open, and we have the plugins tree view, the contracts tree view, sandboxes, artifacts and environments, and tests. Today I'm going to only use plugins, contracts, sandboxes, and artifacts. So from here, you can install or uninstall the known plugins to Taqueria. So for this demo, I'm going to be using a few of these plugins. Let me go ahead and copy a few contracts here. Okay, so I have a few contracts here. Let's try to increment to compile this increment.js Ligo contract, but we can't because we don't have the Ligo plugin installed. I'm going to go ahead and install the Ligo plugin. Now it gives me the ability to compile Ligo contracts. If I compile this contract, it will give me a file in the artifacts folder named increment.tz. So I can't deploy this or originate this this compiled contract yet, because first of all, I need to have my sandbox started, and to be able to start that sandbox, I need to install the Flex Tessa plugin. So let me close the contracts review, and so now I can start this local sandbox.
And the sandbox is also starting up TZKT and stacks.
Yeah, it starts the Flex Tessa sandbox and a TZKT indexer that allows it to do some kind of exploration here. So we can see that it's running and it's at level 6, and our TZKT indexer is also at the same level. So it gives us some kind of a quick health check of our sandbox and the indexer. And in the sandbox, I have some implicit accounts. Some of them have aliases, some of them don't, and we don't have any contracts. So let's try to deploy our contract. To be able to deploy it, we need the Taquito plugin. So I'm going to install it, and now I can try to deploy this. I have two environments, and this sandbox belongs to the development environment. So I'm going to do that, but I can't deploy this because I've not defined a default storage for this file. I'm going to create that storage by going to artifacts and create a file with this name and put some default value in here. If I come back here, I can see that I can deploy this contract. Okay, so now that it is deployed, it also shows up in my in the list of my smart contracts. And first, let me close this one. And on contracts, we can see their entry points and the operations. So obviously, this contract should only have one operation, which is the origination of that smart contract. And I can click on any of these operations to be able to see some details, when that happened, who originated that, and some of the details in about this operation. But I can also see some details about the entry points. So this entry point is named decrement, and it requires an int as an input. So I can go ahead and try to invoke this entry point, which creates a form based on the data type that this entry point requires. And I'm going to enter value here, and maybe 5, and then we will invoke this entry point to this environment, which is going to show us some information about this. And the list of operations now has one more operation in it, which is a transaction. And clicking on it, it will show us some extra information about this transaction. So this is a rapid overview of how you can initialize a project and do some compilation, origination, and interact with the contract that you had. There are so to show you just how the VS Code extension allows us to also scaffold the project, I'm going to create another folder, and oh, that's okay. And okay, we are back to this rather empty sidebar, and we can scaffold one of these projects. So a scaffold comes with a lot of prepared things. So this already has some plugins installed, some contracts in it, maybe different settings than an empty project. And the same can be done here. So we can start this sandbox, compile and originate the contracts here, which I'm not going to redo here. And yeah, so that's a short overview of the end-to-end experience in the VS Code extension.
Awesome. Thanks so much for giving us the demo, Ali.
Sure, my pleasure.
Really exciting to see all these new features that allow users to interact with contracts without needing to know Michelson. Hopefully that's lowering the barrier to entry. Now we're going to move into an open discussion and question and answer period. So anybody that's watching the stream, if you have any questions, please send them on Discord and we'll get them. And we'll move to a panelist discussion here now. Oh, hi everyone. We've got some members of the Taqueria team here, some ECAD members that are not part of the Taqueria team, and then Claude, who was quite well known in the Taqueria, the Tezos community. So welcome, guys. Thanks for joining. There we go. I think your audio is good now.
Yeah, no, it's working.
So yeah, Claude, we're just curious to hear some of your thoughts and on Taqueria and how it's been working into your DApp developer workflow.
Yeah, so actually, it was the first time I see a demonstration of the plugin for VS Code. So it was quite interesting because it was very theoretical until now. So now I understand a little bit better how it works, and it's quite interesting. So what's a little bit fascinating for me is that the first time that I used it, like a few months ago, it was pretty bumpy, and now it's a lot smoother and everything works properly. And I mean, now it's very nice to use it to develop smart contracts. Maybe the question would be like, what would be like the next steps? Do you have any ideas for other plugins that you want to add to Taqueria, or what kind of things you're working on at the moment that are going to come to Taqueria very soon?
Yeah, well, our main focus for the next while is going to be improving our SmartPy developer workflow. So bringing that up to par with Ligo and then solving some of the SmartPy developer workflow issues. We're just trying to reduce the number of steps it takes to get from an idea to something deployed and working. We're going to be improving our support for metadata, token indexing with dipped up. So we're going to have extend the feature where we have the TZKT indexer on our local Flex Tessa instance to also support dipped up. And then as you switch environments from a local environment to a testing environment, you'll be able to point those to public indexers and browse all the assets and contracts that have been deployed on chain. We're going to be, what else do we have coming? We're going to be working on a new plugin at some point, which it does cloning of contracts. So you'll be able to kind of like clone a contract off chain or on chain and pull it into your project and interact with it, deploy it on a local sandbox and work with that. What else do we have coming, Jeff?
So we're going to be also working on like the Mickelson authoring experience. And for power users such as yourself, Claude, there's not many people who write Mickelson directly, but and it's certainly not a requirement. There's plenty high level languages, but we do want to make the Mickelson editing, authoring, and review experience easier. That's something that'll be coming. I think probably in January. And then longer time frame. We're hoping to make some things easier, such as working with multi-sigs. So, like a lot of DAOs and DeFi, they need to prepare operations for origination onto the chain, and then get those signed by multiple participants. And there's a lot of coordination around that, and those type of operations are very sensitive. They need to be right. So we're hoping to make some tooling around that to make those activities repeatable and easier to test. Because it's not too hard to make these type of operations to originate them via multisig, but to get your environment working on someone else's system for review is tricky, and we want to like make that easier, and hopefully make it easier for DAOs and multisigs to generally do the right thing.
And so in tandem with that feature, which we're kind of calling orchestration for now, will be the ability to have a contract dependencies. So if you have a contract that's referenced in another contract's initial storage, Taqueria will be able to understand that and help you with instantiating that storage and then deploying them in the correct order. We've got support for off-chain views and off-chain errors. in the works. We're going to be extending our Michelin editor, which was that graphical UI in VS Code that you could interact with the contracts. We'll be extending that out so you can define your initial storage without knowing how to, without having to define it in Ligo or generating the Michelson. So that should improve things significantly.
And in the VS Code extension that Ali has been developing, when you can select a smart contract in there and select the entry point, and it generates that form for you. So this allows it to be more of an explorative experience for you to call entry points and smart contracts without having to write code. And this is really helpful and interesting for debugging, but also like kind of learning how things work. And there's a few things we want to improve, do there as well, such as right now it will send those operations to your sandbox and execute the smart contracts. But we want to also provide ways to render like an Octave client or a Tezos client command with all the address and the Michelin put into the command, so that you can just copy and paste that out and run it from a particular server or computer that perhaps has a ledger configured. So just basically giving engineers more convenience and making all of these things easier to repeat, and also allowing developers to commit most aspects of their projects to Git as well. So everything is declarative.
Yeah. Also, some improvements to environments. Right now, we have the notion where you can define environments, but environments are going to become a first-class citizen, where essentially you select like a current environment, and your VS Code extension and all the networks you're targeting and all the values in your DApp that are referenced will automatically update as you switch environments, all your account references and keys. So it'll make switching between a local environment and a testnet environment or two instances of the same network much faster and easier.
Okay. And what about dApps? So what do you have in Taqueria to help dApp developers on Tezos?
Yeah, so the first feature we've added is what we call aliasing, and so what it does is it allows you to we have a package that can be installed on from npm.js, which it's a front end library, and it pulls information from Taqueria. So generally, when you're working on a DApp, you have to deploy your contract and then take the address and put it into your DApp and then build it to interact with it. And then if you need to change the contract, you have to repeat that process over and over again. So it will essentially allow you to just define a reference in your DApp. And then as you redeploy the contract, Taqueria will automatically push that into the front end DApp.
And that's that might seem like a kind of a modest feature to have this type of aliasing for things like contract addresses and state within your project, but this is a crucial building block to Taqueria being able to manage your applications in different environments. And one of the Houston's touched on the environment features. One of the first class goals of Taqueria is to give a really good story to manage and deploy your application to different environments, be it a sandbox or a testnet or a mainnet, and taking the pain out of that. Because presently, to redeploy a complex system to different networks and different environments, there's a lot of wiring up and that developers need to do, and there's a lot of easy places to make mistakes. So we're trying to improve that, and I'm looking forward to realizing that properly.
Yeah, and in addition to the contract address, you can pull in the network and like the RPC. So it makes it a lot easier when you want to be switching between things. It supports hot reload as well. You can see an example of this in action on the taco shop. Don't think we have time left to pull it up and do a demo of that, but we could get into that next time. We'll probably be doing that as well.
While we have Claude here, Claude, I think you spent some time using the the type generation feature in Taqueria. Perhaps you did use it in MyTezos DeFi, where you're able to generate TypeScript types based on smart contracts. Could you tell us a little bit about your experience there, and particularly interested to know if there's anything that you think could be improved on that as well? Yeah, go ahead. We have you muted, I think.
You
Go ahead,
you muted me again? Okay. Okay, so yeah, so the problem with MyTezos DeFi is that it works with different DeFi contracts that are on Tezos, and a lot of them have so there are some standards for the storage, but a lot of them also have different properties, and it can be a little bit difficult to make sure that I have the properties right. Above all because of JavaScript, because JavaScript doesn't care that much that a property exists on an object. So sometimes it happens that I try to access that property and actually doesn't exist. So it's true that the plugin to generate the contract types has been very helpful because I've been able to generate the types for the contracts and I've been able to use it in TypeScript. So it's reduced the amount of errors that I got when accessing different properties in the storages of the contracts. So that's a very great feature for dApps, I would say. So if you work with TypeScript, you can use it, and you know that when you use Taqueria and you're going to get the storage from the chain, you know that you can type it properly, and you don't even have to do it manually because the plugin is going to do to generate the storage for the type for the storage for you. That's a great that's a very valuable tool. Yeah, and it worked very, very great. I don't see anything any sort of feature right now.
So one of the interesting things in your use case is that in developing Taqueria, where most of our work is centric around the code and the smart contracts that the developer, the user of Taqueria, is authoring. And that's a reasonable place to start out. But in your case, you're using and you're calling smart contracts on the chain. So these are sort of like public goods or publicly available APIs that are represented as smart contracts on the chain. So that's something we should acknowledge a bit more probably in our documentations and our how-to, is how to generate types for an on-chain contract that the developer doesn't necessarily maintain, and the source code for which will not be in their repository. And that's an important aspect, especially with like oracles and other public good contracts like dexes and different things. So something we could probably make more apparent and make more.
Yeah. I think also it's very great for integration tests. So if you use something like Jest, and then you generate the types for the storage, and you know that the tests are a little bit safer because you know exactly TypeScript is going to give you some kind of warning if you try to access a property that doesn't exist according to its type. So it also enhances the safety of your tests and makes them better. And yeah, so it's great for testing and also for dApps.
Yeah. Did you guys know also that contract that types generator plugin can also generate Jest integration test stubs and it does it for each entry point of a smart contract?
Yeah, it does it via the Jest plugin, but you can essentially it'll look for every entry point and it'll create boilerplate with the correct parameters. It's trying to make things a little bit easier. Awesome. Yeah,
I think I saw something like that. Yeah.
Zane and Davis, do you guys have any questions? Oh, one sec, Davis. Sorry.
We still don't have audio from you, Davis. You're not muted, but I think it may be that your mic is.
Can you
not,
hear me now?
Yeah.
Awesome.
Yes.
Yeah. I was muted, I think, from my headphone. But yeah, don't have much questions. I think everyone else has asked all the right questions for me. But yeah, it was really informative. I was really glad to see what Taqueria is capable of now. And I think everyone has kind of mentioned the point that there's a lot of barrier of entry when it comes to Mickelson and managing contracts in general. And I feel like this definitely would ease it by a huge margin. So I myself am not a Mickelson expert like probably like Claude is, but I will definitely start playing around with it and getting my hands dirty because this seems like super accessible, super convenient to use, and I'm sure you guys are working super hard to make continuous improvements. So yeah, I'm excited.
Yeah, and thanks, Davis. For viewers, Davis and Zainin both work on the Taquito team, and Taquito being sort of the Web3 library for Tezos. And yeah, Davis, you touched on something there as well. Is there is for developers that are not in the Tezos ecosystem and have looked at it from afar. There's a misconception that we have this weird programming language called Mickelson, and everybody needs to write everything in Mickelson. Mickelson is a low-level language, and it's not necessary to write or be able to read Mickelson. Um, and so Taqueria is aiming to make it easier to onboard outside new developers into the Tezos ecosystem and get them up and running and started with high level languages such as SmartPy or Ligo and Archetype. And again, you don't need to learn Mickelson or know what Mickelson is to be able to use Tezos. But also an ancillary goal of Taqueria as well is to actually demystify Mickelson, because it's not really that scary. It's actually pretty straightforward, and we can take a lot of the scariness out of Mickelson as well over time. So that's one of our goals here too.
Yeah, that's perfect. Thanks, Jeff. Thanks, everyone.
Awesome. Well, does anybody else have any comments, or should we wrap up?
Yeah, let's probably wrap up. I think so. The next one of these, this was our first office hours session. Thank you, Houston, for organizing and getting everything put together, and all the participants here. The demos are good. And we're going to be doing these fortnightly. So the next one will be in approximately 2 weeks from now. Yeah, we're. If any of the people watching this after the fact have topics you'd like for us to discuss, please reach out on social media or join the next one with live questions. And I think on the next session we should probably do a demo of types generation in Taqueria, and maybe also something like hot reloading as well.
And declared account instantiation and funding, and probably generating test stubs as well. It seems like that's a feature not many people know about yet. Awesome. Well, thanks for joining, everybody. We'll leave it here and hope to see everybody in the next one.
Thank you.